Okay, so we're at our mid-unit study guide day, talking about proportionality. So remember, there's several ways we've looked at proportionality. We've looked at proportions in tables, where you make ratios and simplify to unit rates. We have looked at proportions in graph form, as you see here at the bottom of the page. And we have looked at proportions using constant of proportionality. So we're going to take a look at all three of those things today. You definitely are able to use the calculator on this study guide. And at this point, you've probably already completed the problems and you're looking for the answers. So make sure you write the answers down. Make sure you're ready to answer questions. And if you are successful on this study guide, if you know what you're doing, you will be ready for the test tomorrow. So let's go through number one. Are the values in table A proportional? So we're looking at a table, not a graph. First thing you're going to do is take tables from the graph and write them as ratios. Remember, we want to write these in a form of y over x. So we're going to be looking at our bottom table values first and actually flipping those and putting them on top. So let's look at the first one here. First column of the table, we have an x value of 2, y value of 6. So we're going to make a ratio of y over x. That's going to be 6 over 2. We're going to do the same thing for the next column of the table. It's going to be 10 over 4. Write that one up here where I have room. Next is going to be 14 over 6. And these are generic values. They don't really mean anything other than their number. And then 18 over 8. So now what we're looking to do is simplify each ratio down. If they all simplify to that same unit rate, then we're good. They'll be proportional. So let's look at the first one here, 6 over 2. 6 and 2 have a common factor of 2, so we can divide by 2 on the top and on the bottom. And we'll get 3 over 1. Or we'll get that constant of proportionality of 3. Let's look at our next ratio. We have 10 over 4. 10 and 4 have a common factor of 2 as well. And we'll get 5 over 2. Now 5 over 2 does not match up. It's not the same unit ratio as 3 over 1. So as soon as we see that, we're done. We don't even have to mess with the other two. So are the values in table A proportional? No. On to table B. Number 2 says, are the values in table B proportional? So this one is written vertically instead of horizontally. It doesn't change anything. Again, we're looking from our y value to our x value. So our first ratio in this table will also be 6 over 2. Both have a common factor of 2, just as they did in the last problem, and we would get a unit ratio of 3 over 1. Our next value in the table, 15 over 5. The common factor of 15 and 5 is going to be 5. So divide by 5 on top and bottom, we're going to get 3 over 1. Now you have to go all the way through. You can't just assume that the last two are going to be the same unit ratio. We have to show our work. So 21 over 7. Common factor of 7. It's going to give us 3 over 1. And last but not least, we've got 24 over 8. I'll jump up here with it. Common factor of 8 would simplify to 3 over 1. So all values in table B have a unit ratio of 3 over 1, a constant of proportionality of 3. So are those values proportional? Yes. Number 3 should be written quite a bit bigger on your paper, but it says, are the values in the graph proportional? First thing we want to look at is what's the graph about? So at the top it says money. Let's look at our x value. And it looks like our X value is number of weeks, and our Y value is total savings. So if asked what this table is about, it's about money saved in a given number of weeks. So what it really wants to know is the number of weeks proportional to the money saved? Let's take a look. There's no points, but you can plug in the ordered pairs anywhere where they intersect. So there should be an ordered pair here, 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 and here. And they're actually anywhere along the line, but we like to put them at those convenient spots where we have two intersecting axes. So are the values proportional? If we're looking at it as a graph, we quickly know that yes, they are. Because it's a straight line through the origin. And number 4 is a pretty important part of this. It says, prove your answer to number 3 with simplified ratios. So I want to make sure you know how to create ratios from a graph. So here's how you do that. You pick a point that you see, and you keep in mind that your X value is all of these numbers, and your Y values are all of these numbers. So if I pick a point, like this one right here, that has a Y value of 94 and an X value of 2. So it's 94 over 2. What that really means is $94 in 2 weeks. If we simplify that down to a unit rate, we're going to divide by 2. And you're going to get $47 per week. That should happen at any point that you pick on this graph if it is truly proportional. So let's try it for one more. Let's pick up here. Let's pick this one. That's $282 in 6 weeks. So again, if we're going to find a unit rate, we're going to divide by 6 on this one. And it should come out to $47 a week. 6 divided by 6 is 1. Let's get the calculator. And let's go ahead and divide 282 by 6. And just like it's supposed to, it comes out to 47. And to truly prove that, you would show it for every point that you see. I'm just going to show you 2 on the video. We already know it's proportional, but I want you to see that you can take that information from a graph and prove proportionality this way as well. So whoever's saving money here, they're saving $47 a week. On to the back page. How can you tell if values in a table are proportional? Answer to that question would be they simplify to the same unit ratio. So we've done that a couple times in the study guide already. Number 6, how can you tell if values in a graph are proportional? Answer to that question would be that they form a straight line through the origin. And now we're going to look at a table for number 7 and 8, and then we have a final question, number 9. So looking at the table, number 7 says find the constant of proportionality, which in other words is the unit rate. They use K as the variable for constant of proportionality, so we're going to find what K equals. In order to do that, you first of all want to make sure the table is proportional. So we're going to set up 4 ratios. Of y over x. Now if you have money involved, it's usually easiest to make money the y value, the dependent variable. So we're going to set up, and I'm going to use a different slide. You guys probably used a different piece of paper. I'm going to set up all these values on another slide so we have some room to work. Okay, so we have 4 values here, 4 ratios. The first one is 98 over 8, and let's remember that this stands for $98 for 8 shirts. And if we find a unit rate, we would divide by 8 on top and bottom. And use your calculators, but it's going to come out to 12.25 over 1. And what that stands for is $12.25 for 1 shirt. And that will be our constant of proportionality, meaning the cost for 1 will be $12.25 if in fact it's true for all 4 of these. So on the second one we would divide by 12 to get our constant of proportionality, and 147 divided by 12 is also going to be $12.25 if you check it on your calculator. Third one we're going to divide by 30. You will also get $12.25 over 1. And last but not least, $490 for 40 shirts. We're going to divide by 40. Again, you can show this on your calculator. I'm not going to pull it up on the screen, but it'll be $12.25 for 1 shirt. So to answer the question, what is the constant of proportionality? It's $12.25, meaning $12.25 for 1 shirt. Number 8 says write an equation in the form of K. Remember, K is constant of proportionality times X equals Y. Remember that the X value is our number of shirts and the Y value is the cost. So let's take a look at how you write that equation. So we know our constant of proportionality. We know our K value. It's $12.25. We would multiply that times the number of shirts, or our X value, so times X. When we write it like that, we probably ought to show multiplication like this so we don't get confused. $12.25 times X, or the number of shirts, will give us the cost. So it's really that simple. This is our equation. We could plug in any number of shirts right here and multiply it by 12.25. and that would give us our cost, our Y value. Last one, Jeff walked 2.5 miles in 3/4 of an hour. How far does he walk